Problem number 17, find the number of integer solutions to the equation this. Okay, when we have this, because we have x, y, and this, one important thing in number theory problems like this, consider this, it is so much useful. And from qualifying level up to IMO, y prime d, and their GCD is d, their GCD of x prime y prime is 1. Now I replace 19x prime d plus 93y, which is y prime d, equal 4xy, 4xy x prime y prime d squared. We know d is positive because it's GCD, always positive. If we divide both sides by d, 19x prime plus 93y prime equal to 4x prime y prime d. And here we know x prime divides this, so x prime divide the only term that is left, 93y prime. Because x prime, y prime are co-prime numbers, so x prime divide 93. And also you can say y prime similarly divide this and this, so y prime divide 19x. They are necessary conditions. So because y prime and x prime are relatively prime, so by using Euclid lemma, we can say y prime divides 19, so y prime can be plus minus 1 plus minus 19. So if we check, for example, one of them, y prime equal plus 1, case 1. Then if we replace here 19x prime plus 93 equal to 4x prime d. And now we can say 93, if we take these to right hand side and factor from x prime, 4d minus 19. Now 93 is what? Is 3 times 31. If you check, this number is 3 mod 4. So is, let me check, 4d minus this is 1 mod 4, because if you add by 4 it will be 1 mod 4. If you divide, because negative 19 is 1 mod 4, 19 is 3 mod 4, and negative 19 is 1. So here it can only be 1, or, and we know d is at least 1. Okay, 193. And also we can say it is equal to negative 3, because it can be integer, negative 31. All of them have this. So let's consider each case. The first case, d will be 5. When it is 1, it will be 93, x prime 93. For this case, d will be, we calculate 40 minus 19 is this. So 40 is 19 plus 93. So if you divide, d will be 28. And in this case, x prime is 1. For the second case, d will be 19 minus 3, 16. D will be 4. And x prime will be what? Negative 3 times negative 1, negative 31. In this case, d will be 19 plus this d will be negative, and that's a contradiction for this case. So let's find x and y for each of them. In this case, x is 93 times 5. And y will be what? Y prime is 1. We know it's y prime d. 1 times 5, 5. For this case, x is this times this, 28. And y also will be 28. For this case, x will be negative 31 times 4. It will be negative 124. And negative 124. And y will be what? Y will be y prime d, which will be 4. And we have these 3 cases for this one. Now, the next one, we consider what? Case 2. Y prime equal to negative 1. Then we can say what? We can say, if we replace y prime with negative 1, 19x prime minus 93 equal to minus 4x prime d. And here, if we take this to left hand side and factor from x prime and take this to right hand side, x prime times 19 plus 4d equal to 93. And now because it is 93, this one is what? 4k plus 3. So because it is 3 times 31, the only possible cases are 3, 31, 4k plus 3, negative 1, negative 93. And for each of them, the first one, it is at least 140, so it will be at least 23. So we can cancel this, cancel this, cancel this. So we only should check this. These GCD should be positive. So for this one, 4D is 31 minus 19, 12. D is what? D is 3 because it is 31. X prime will be 3. So x prime is 3. So x is what? D times x prime, 9. And y is what? Negative 1 times d, which will be d is 3, will be negative 3. So we found one answer here, two answers, three answers, four answers so far. 19 and negative 19 is left. So case 3, y prime is negative, let's consider first 19. Our main equation is this, so we can say 19x prime plus 93y prime, which will be 19, equal to 4x prime 19d. And if we cancel both sides by 19, then we have x prime plus 93 equal to 4x prime d. Okay, and we can say 93, if we factor from x prime, 4d minus 1. Now, it is 3 times 31. So here it is 4k plus 3, the remainder. So it can be 3, 31, negative 1, negative 93. Because d is at least 1 positive, so these two cases are impossible. For this one, d is 1. Because it is 3, it will be 31, and also in this case, 31, 3. So d is 1. Now, we can say x prime is 31, so x is 3 times this 93 and y is 19 times 3. 19 times 1, sorry. D is 1. Okay. So y is 19 and also x is x prime d. Here d is 1. So x in this case is also what? 31. Okay. So for this case, d is what? 32 over 4, 8. So x is x prime d, 3 times 8, 24. And y is 19 times 8. Okay, we found two answers also here. So let's see how many answers have we found so far. 1, 2, 3, 4, 5, 6 answers we found so far. Now let's consider last case. Case 4, when y prime equal to negative 19, if we replace here, then we will have 19x prime plus 93 times minus 19, 4x prime, negative 19 times d. If we cancel 19 here, then we have x prime minus 93 equal to, here we can say negative 4x prime d. Okay, so if we take these to left side, these to right side, and factor from x prime, then we have 1 plus 4 d equal to 93. Now it is 3 times 31. So we can say what? It is, the remainder is 1. So you can check 1 here, 93, negative 3, and negative 31. So if we check 1, okay, if you check 1d will be 0. In this case, if you consider x equal to 0, so here it's impossible because y prime is 19. But at the first of the problem, because we've divided by d prime, all of them are in the case d is positive. We consider the GCD when both of them are not 0. So x0, y0 satisfy the equation. So we consider also this. So until here, 7. Now let's check 93. Because in this case, a GCD of x and y doesn't, we can say undefined. So here we calculate this, except this case, for example, 0 or other numbers, we can use GCD. The rest will be same. So 93, then 40 will equal to 92 and d equal to 23. So here we find another answer. It's 93, it will be 1. So x will be 23 and y will be negative 19 times 23. Another answer. So 6 answer, 1 answer here, 7 answer here. So we have 8 answers. So the number of answers equal to 8. So the answer of this problem is 8. Problem number 18, find the number of integer solutions to the equation. This with x1 greater than equal x2 greater than equal x3 greater than equal 0. So exactly 2 days before the exam, I released a video, useful ideas for SMO 2022. In that, if you saw that video, it's so much useful for this problem. x1 plus x2 is 20 plus x3. So I check, for example, at first x3 equal to 0. So it will be 20, and x1 is greater than equal x2. So you can say it's 20, 0, and both of them greater than equal 0. And then 19, 1, you write until what? Until 10, 10. So how many numbers do we have? 11. If x3 is 1, then it will be 21, and both of them are greater than equal 1. So it can be what? 20 and 1, 19 and 2, 11 and 10. So how many do we have answers? 20 minus 10, 10. And the next one, if it is 2, then 22, we have 22 until 11, 11. How many answers do we have? 10. Now, if I copy, so if x3 is 3, then here, what can we say? 23. You can say 20 to 3 to 12 and 11. 23. So 20 minus 11 will be 9. And if you check also next one, so if we calculate, we have 11, and also it will be again 9. If it is 4, then 24 to 12, 12. If we calculate, it will be 9. And the last terms, you say 19 is 39. You can say 2019, one case, and if it is 20, 20, 20. So one case. So the answer is sum of all these cases. We have 11, then we have 10 plus 10, we have 9 plus 9, 2, we have 1 plus 1. So here we can say it is 11 plus 2 times 10 plus 9 to 1. And it will be 11 plus 2 times here. It is what? 10 times 11 over 2. You subtract, you factor from 11, it will be 1 plus 10. It will be 11, 11 squared, which equal to 1 to 1. It is considering some small example and find the pattern, not only pattern of the numbers, pattern of the solution. It is so much useful. Exactly 2 days before exam, I told you, and I solved some problems, and I said that in SMO 2022, you will see same problems. Also for round 2, I will do the same